So, dear friends, once again, welcome. Let us discuss about the shear force and a bending moment concept with the sign convention. In the previous lecture, we have in lectures we have discussed about the support reactions of the standard beams like cantilever beam and a simply supported beam with different loading conditions. In this, our focus is the shear force and the bending moment concept with sign convention. Okay, so once again, a beam. So a beam, obviously, what is the beam? So beam in which length is much greater than other two dimensions like width or thickness. And the beams can be divided into two parts: statically determinate beams and statically indeterminate beam. Okay, and what is the statically determinate beam? So if total number of reactions in the beam is equal to number of useful static equations, then it is known, the beam is known as the statically determinate beams. Means uh, uh, what suppose a beam, if we talk about the a simply supported beam where one and means B is supported by roller and A is supported by hinge. So how many supports reactions will be there? Okay, depending upon the loading conditions like this one and like this one. This is P1, this is P2. So we have three reactions. Okay, means this is VA and it is VHA and it is RB. So how many reactions? Number of reactions is equal to 3. And how many? The static equilibrium equations we have. So number of static equilibrium static equilibrium equations. So 3. How? It's very obvious. Summation of fx is equal to 0, summation of f y is equal to 0, and the summation of m, suppose in 2D, z about 0. Okay, so and if the indeterminate, the beam will be known as the indeterminate beam when the total number of reactions, okay, like a number of reactions, number of, this is suppose total number of reactions are more than the number of equations. Okay, this is number of equations, suppose r number of reaction, r number of reactions, and e is number of equations. So in that case, the beam becomes the indeterminate beams. Okay, and what are the types of determinate beams? So if it has three, means there are three types. First one, simply supported beams and overhanging beams, and then cantilever beams. Simply supported, simply a beam is just supported by hinge or roller. Okay, the overhanging beam, and the same beam, suppose this is the beam and one hinge is here, and here suppose the roller is here, and this is the beam which is not supported, so that's why it is known as overhanging beam. And the cantilever beam, like this one end is fixed, and this other end, this A, uh, or suppose B and this is A, so B and is free. Okay, and व्हाट अबाउट द इनडिटर्मिनेट बीम्स? कौन कौन से बीम्स हैं जो इस कैटेगरी में आता है? तो फिक्स्ड बीम्स विच इज आल्सो नोन एज बिल्ट इन बीम्स, and the next is propped cantilever beams. Okay, so propped cantilever beam is what? So cantilever beam suppose has uh, the uh, like this one, and this end is suppose supported by a roller. Okay, so this cantilever beam then becomes the propped cantilever beam, and the next the continuous beam. So in continuous beam, the supports will be more like here one support, here one support. The number of supports will be there. Okay, either hinge or roller kind of things. Okay, so in this way we have classified the beams into statically determinate beams and statically indeterminate beams. So it statically determinate beam also has three beams, and indeterminate beams also has three beams. So in this we can like a continuous beam. So see here, due to more number of supports, the number of reactions means R will be greater than E. That's why we'll be not able to solve. Okay, now what is shear actually? So shear in this figure, our now our query is, what is shear next to the beam? So this we want to know, and suppose this is the surface. You can see here the surface, and if you see the cursor, and this is the direction of shear, which is denoted by tau, and this is the shear stress acting on the cut face. Okay, and this face is known as cross sectional area of the cut. So you can see the how the force is acting. Okay, so it will try to shear off the beam. Okay, once again the shear, like the beam, and the beam is supported by suppose fixed beam, and this is the beam, and suppose here some force P is acting, so it becomes like, and its a direction is, you can see the beam is horizontal and force direction is vertical. So what it will try to do, it will try to cut the beam into two parts. ठीक है, so ये जो this surface here the shear force is acting. ठीक है, ये आपस में स्लाइड होने की वजह से जो ब्रेक डाउन होता है, दैट इज नोन इज द shear force. Okay, what about bending? So a beam can be either deformed by the shear force or the bending moment. And why we are studying this? Ultimately we want to know our structure is how much strong, and means how much it is durable, मीन्स कितना लंबा चल सकता है, कितना लोड बियर कर सकता है, उसी का एनालिसिस कर रहे हैं. सो उसी एनालिसिस में शेयर फोर्स एंड बेंडिंग मोमेंट वी आर गोइंग टू डू. ओके, सो सी द बेंडिंग मोमेंट क्या है. सो बेंडिंग मोमेंट में क्या हो जाता है आपका, द डिफ्लेक्शन अकर्स. ओके, डिफ्लेक्शन अकर्स. सो इफ यू सी दिस फिगर, तो अर्लियर दिस वाज द एक्सिस. Suppose x-axis. Okay, x-axis, but now see what happened, it becomes now curve. Okay, so this is due to the bending. आप देख सकते हैं here this end and what about the middle portion? This the middle portion is more deflected. क्यों? क्योंकि मिडिल पोर्शन में सपोर्ट्स नहीं है. सपोज इन दिस केस एंड में जनरली सपोर्ट्स रहते हैं, और जहाँ पे सपोर्ट्स रहते हैं वहाँ पे आपका डिफॉर्मेशन कम होगा. ठीक है, डिफ्लेक्शन कम होगा, और जहाँ पे सपोर्ट्स नहीं है वहाँ पे डिफ्लेक्शन ज़्यादा होगा. ठीक है, एंड सो एंड व्हाट अबाउट द टेंशन. ठीक है, इफ़ यू सी द सरफेस हियर दिस वन. ठीक है, तो ये कैसा हो जाता है, एंड द आउटर सरफेस, दिस इज द आउटर सरफेस एंड दिस इज द आउटर सरफेस. ठीक है, सो आउटर सरफेस ये हियर द सरफेस कम्स इन द टेंशन. but the inner surface here, it is in compression. ठीक है। इसी की वजह से देख सकते हैं एक्सटेंशन ऑफ, इफ यू कंपेयर दिस सरफेस if you compare with this, ठीक है, the length of the curve, so this surface, the outer surface has more length. Okay, so more length tension की वजह से होगा, extension की वजह से होगा, it got extended. Okay, and this is the real example. You can see here real example, and which type of this beam, it is beam. Okay, beam, which type of, so it is rock concrete beam, and due to shear, see what happened, see here, okay, so due to shear force there is failure, ये पोर्शन ऑफ शेयर ऑफ हो गया है, ठीक है, मीन्स दिस इज ट्राइंग टू बी सेपरेट, ये वाला सपोज दिस इज 1 एंड दिस इज 2, सो बोथ पार्ट्स ड्यू टू शेयर फोर्स इज ट्राइंग टू बी सेपरेटेड, ठीक है, इसका मतलब डिफॉर्मेशन. ओके, एंड this again, the due to tension actually what happened, and due to compression actually what happened, and due to shear actually what happened. So shear already we discussed. So tension में क्या हो जाता है, suppose this is any body, or suppose any rod, the better example is this is rod, okay, and there is suppose the gripper for holding the rod. So if the tension is applied here, tensile force is applied here, like F, so it becomes like that, ठीक है. So this portion just like our neck, ये पोर्शन ड्यू टू एक्सटेंशन ये क्या हो जाता है, डायमेंशन डिक्रीजेस, ठीक है, एंड एंड का डायमेंशन देखेंगे, तो विथ रिस्पेक्ट टू दैट दिस द मिडिल डायमेंशन डायमीटर गॉट रिड्यूस्ड जस्ट लाइक आवर नेक. तो इसमें आप देख सकते हैं. देन व्हाट अबाउट द ड्यू टू डिफॉर्मेशन, सपोज मटेरियल्स, हाउ इट लुक्स लाइक, ठीक है, एंड हियर ड्यू टू कंप्रेशन the it is trying to come out, the like materials are trying to come out due to compression. And now the most important thing, the sign convention. But why it is required? So to draw shear force diagram and bending moment diagram, ठीक है. And why shear force diagram and a bending moment diagram? In short form, this we write as FD, and this we write BMD, bending moment diagram, ठीक है. Okay, and why it is required? Because we want to know the profile of the deformation, so that we can take care while designing, while thinking about to design the bridge, like a railway bridge, ठीक है. So what are the possible failures that we need to consider, ठीक है. That's why sign convention is required to draw the SFD and the BMD, means the profile of deformation. Okay, so suppose the beam, and this is due to the beam, you can see this one here. So beam got sheared off due to the shear force, and what is the shear force firstly? So shear force is what? Shear force is basically the vertical forces, like better to know this, the definition, what is the shear force. So here you can see the shear force, it is algebraic sum of all vertical forces on beam. So no need to get confusion, like पहले जो forces होते थे, अब shear force में क्या difference है? So shear force is nothing, it is vertical force acting on the beam, parallel to the beam, not no, sorry, perpendicular to the beam, not parallel to the beam. Okay, but the cross section, okay, it will parallel to the cross section. If you see the like the beam, this is the beam. Okay, so like this cross section, okay, this cross section, it is parallel. Okay, so it is simply nothing. The shear force is vertical forces. So what we have to do, we have to sum up all the vertical forces. Okay, and then what is bending moment? So bending moment is also same. The algebraic sum of the bending moment means moments about any point. Okay. So our focus is now the shear force diagram, in which we want to know what is our साइन कन्वेंशन. ओके, सो ये आप देख सकते हैं बीम ड्यू टू शेयर, ये आपका एक्स सेक्शन हो गया सपोज, एक्स सेक्शन. ठीक है, सेक्शन के आप देख सकते हैं दिस इज द लेफ्ट साइड एंड दिस इज द राइट साइड. ओके, एंड लेफ्ट साइड suppose the force is upward. Okay, better to understand is like this is the beam, the name I am giving A and B, and suppose we divided it into two parts, xx. Okay, so this is the left hand side, this is the right hand side. Okay, and suppose at this end and A there is a reaction, and the reaction name is RA, and direction is upward. And suppose there is a downward force, and name we are giving suppose W1. Okay, so this R1, the upward direction, we take positive. ठीक है, the take positive, this negative. And what about the right hand side? So right hand side, the same situation. This is the reaction RB, and this is suppose the force W2, load W2. Okay, so RB direction minus, this W2 direction plus. Okay, so in this way we take the sign convention. So what about this? आप देख सकते हैं द पॉजिटिव शेयर फोर्स, एंड बीम का आप देख सकते हैं, एंड दिस इज द अपवर्ड लोड, एंड दिस इज द डाउनवर्ड, दिस इज द डाउनवर्ड एंड दिस इज द अपवर्ड. ठीक है, so left side it is if it is the upward load, then we take positive, and right side downward, then means this combination we say the positive shear force. The negative shear force, left side downward, right side upward. So this combination we say negative shear force. And let us implement this sign convention for the shear force. So again coming back to this one. Okay, and here if you focus the beam, so this is the beam, one can see the beam name is A here, B here, and here W1 is acting, here W2 is acting, here W3 is acting, and the length of the beam is suppose it is L. Okay, and then अब हमें क्या करना है, सेक्शन लेना है. तो सपोज यहाँ पे हमने सेक्शन लिए, यहाँ पे हमने सेक्शन लिए, सेक्शन नेम 1 हमने नाम दे दिए. ठीक है, सो व्हाट अबाउट द इट्स अ डिस्टेंस फ्रॉम ए, सो इट इज x. And what about W1 from this section? So it is A. Okay. So as we know, shear force is what? The shear force is the summation of vertical forces, taking care of its direction, positive, negative. Okay. And so here, the net force on the left side of the section. Okay. Means we're talking about this section. This section. Okay. So this section, this is R A, so positive direction. Okay. And W1 is acting downward direction, that's why minus, and it is equal to 0. So F is equal to what is? F is equal to uh, okay, the force F is equal to RA minus W1. Let us what is this? Let us discuss this one. The net vertical forces on the right side of section. Now our see right side. Our focus is here, the right side of the beam. So W2 downward, W3 downward, downward, but positive, positive we have taken, and this is RB. So RB here, it is taken, RB is here acting upward direction. That's why minus sign. Okay. So all focus is here, this equation. Okay, this equation. So that means what about the लेफ्ट हैंड साइड राइट हैंड साइड, ठीक है, और उसमें कैसे साइन कन्वेंशन को इम्प्लीमेंट करते हैं, एंड वाई इट इज़ रिक्वायर्ड समटाइम्स लेफ्ट साइड समटाइम्स राइट साइड कैलकुलेशन. ठीक है, सपोज आपने लेफ्ट साइड से कैलकुलेशन स्टार्ट किए एंड बी के कैलकुलेशन करते करते आप बी तक पहुंचने वाले हैं, एंड ड्यू टू दैट कैलकुलेशन एक्सप्रेशन बिकम्स लेंदी. Okay, so to avoid that, why not to then take, means why not to take our calculation focusing on the राइट साइड. ठीक है, अब उससे क्या लेंगे, बी के नज़दीक पहुंच गए हैं, अब बी के फोकस करते हुए आप कैलकुलेशन करेंगे. सो योर इक्वेशन विल बी मीन्स देयर विल बी लेस नंबर ऑफ वेरिएबल्स इन्वॉल्व. ठीक है, ज़्यादा कैलकुलेशन नहीं करना पड़ेगा. सो in this way, the sign convention for the shear force we got to know. Now what about the sign convention for bending moment? So what about sign convention for the bending moment, for the bending moment diagram? Okay, so here, like this is the initial beam, and suppose it becomes like this due to this moment. Okay, due to this moment. So this type of curve, अब इस टाइप के कर्व में क्या हो गया, this outer surface in tension, this inner surface is in compression. ठीक है, so these are we consider the positive bending moment, and just it's opposite it. If it becomes like that, and this is suppose A, this is suppose B, and due to the moments at the ends A, B, it becomes, so we consider the negative bending moment, and this is known as the sagging, and this is known as hogging. Okay, so this is explained here with this figure. So this later discuss this lower one, the beam. So due to the forces acting at the ends, it becomes, and how it will create the bending moment. It will create like this one, like this one. So this is the sagging positive. Okay, means positive bending moment. And just opposite to this, see here, here, then here this surface, outer surface, comes in tension, and this kind of deformation is known as hogging negative. And this is very general thing, like how the tension force is being applied here. Okay, and the compression here. So the tension here due to extension, what happen, the suppose beam length increases, means positive, here beam length decreases, then negative. Okay, once again see here positive shear and negative shear, we are repeating same again and again so that you can remember. ठीक है, अब देखिए पॉजिटिव शेयर है, अब देख सकते हैं दिस डायरेक्शन, दिस इज द एक्स एंड दिस इज द वाई. So better to remember this. See the left side, okay, and the left side, and this V is what, this V is shear force, whatever the force is, that is shear force. ठीक है, vertical force, and its direction is here in the positive y direction. ठीक है, so that's why positive shear force. And अगर उसी लेफ्ट साइड को देखें, and the force is acting in negative y direction, okay, that's why negative shear force we are seeing. Again here the sagging moment, hogging moment. Sagging means positive and hogging means negative. And this already we have discussed, shear force and bending moment here, but example, the calculation is for the shear force. In this way we have discussed about the basic concept of shear force and the bending moment, and this is foundation for the shear force and the bending moment diagram. ठीक है, तो shear force, what is the shear force, and firstly हमने क्या किए, क्लासीफाई किए बीम कितने टाइप्स के होते हैं. So statically determinate and the indeterminate, and what is the meaning of those, then how the shear force acts, and because of that what happens due to bending. There may be possibilities of either the beam can be deformed due to shear force or due to bending, and this is the real example how the beam got cracked here, and this is how what happened in the beam due to tension, compression, the shear. And then the sign convention we have discussed for shear force and for the bending moment. With this, thank you.